Today we will be discussing operations and composition of functions. So operations is just your typical add, subtract, multiply, and divide, and later we'll talk about what composition means. So we are going to start with operations. So the first type of operation, the first example gives you an example of an operation which is adding. We're given that f of x is 2x minus 5 and g of x is 12 minus 4x. We want to find f of x plus g of x. So it's just telling me to add 2x minus 5 plus 12 minus 4x. Whenever we add polynomials, we're just combining like terms. So the like terms here are 2x and negative 4x, which added together gives you negative 2x, and then negative 5 plus 12 gives you 7. So this would be your final answer. The way you denote that is f plus g of x is negative 2x plus 7. So these are all the different operations. You have addition. So if it's written f plus g of x, that's the same as saying f of x plus g of x. If you have f minus g of x, that's the same as saying f of x minus g of x. Similarly with multiplication, f times g of x is just f of x times g of x. With division, it is still the same thing, f of x over g of x, but whenever you have a denominator that is a polynomial, there are restrictions on the denominator, so make sure your final answer lists any and all restrictions on the denominator. So we're just going to do a few examples. The first one, you're given an f of x, a g of x, and an h of x. So you just have to simply see which functions you're looking for. F plus g of x means f of x plus g of x. So we are adding f of x, which is x squared minus 4x minus 5, plus g of x, which was x minus 5. Again, since we're adding, we're combining like terms. So your final answer is x squared minus 3x minus 10. Problem number 2 is a subtraction problem. So you're taking g of x and you're subtracting h of x. So g of x was x minus 5 minus h of x, which was negative 2x plus 6. Now remember, whenever you subtract polynomials, you need to distribute your negative to the second parenthesis. When you do that, you end up with x minus 5 plus 2x minus 6. Now it's just simply combining like terms, so your final answer will be 3x minus 11. Moving down to number 3, it's an example of multiplication. So you're multiplying h of x and g of x. H of x is negative 2x plus 6. G of x is x minus 5. You can do that with FOIL, distributive property, the box method, whichever way you want, but you do need to multiply those all together. When you do that, you end up with negative 2x squared plus 10x plus 6x and then minus 30. Then to get your final answer, you do combine like terms, and that does leave you with negative 2x squared plus 16x minus 30. The last problem is a dividing problem. So you're dividing f of x divided by g of x. So f of x was x squared minus 4x minus 5. G of x was x minus 5. Now with any rational functions, you do want to try to simplify if possible. The top does factor. So when you factor the numerator, you get x minus 5 times x plus 1, still over your denominator of x minus 5. You do have common factors, so the x minus 5s cancel out, and that leaves you with your answer, x plus 1. But note, you do have to state any and all restrictions on x, and in this problem, if x is 5, it gives you a denominator of 0, which is not possible in math, so therefore, your restriction on x is x cannot be 5. So your answer is x plus 1, where x is not equal to 5. All right, moving along. The second type of problem you might see with operations is finding the numerical value. So now if you notice, you're still given an f of x and a g of x, so that you have your functions. But now, instead of g minus f of x, it's g minus f of 2. So what that means is everywhere you see an x, you're going to plug in the value of 2. So g minus f of 2 is basically g of 2 minus f of 2. So g of 2 is taking g of x and plugging in 2. So 7 times 2 minus 10. Then from our problem, we're subtracting f of 2. So I plugged in 2 into f of x. And now I'm subtracting those two things. I simplify. 7 times 2 is 14, minus 10 is 4. When I simplify f, I get negative 3. 4 minus negative 3 gives you an answer of 7. For problem number 2, you're doing f times g of negative 1. So therefore, you are plugging in negative 1 into both f and g, simplifying it, and then multiplying those two answers together. So I plugged in negative 1 into f times plugging in negative 1 into g. When you plug in negative 1 into f and simplify it, you get 0. When you plug it into g and simplify, you get negative 17. So since it's f times g, I do 0 times negative 17, and that gives me an answer of 0. The next problem is g divided by f of negative 2. So that's plugging in negative 2 into g and f and then dividing your answers. So I plugged in negative 2 into g on top, into f on the bottom. 7 times negative 2 is negative 14 minus 10 is negative 24. When you simplify the denominator, you get 9. Negative 24 divided by 9 reduces to negative 8 over 3. So that is your final answer. Because you did not end up with 0 in your denominator, you don't have to worry about restrictions in this problem because it did give you a final numerical answer. For number 4, we're adding. So now we're adding, plugging in 5 into f, plug in 5 into g, and add your solutions together. So when I substitute 5 into f, I get this. When I substitute 5 into g, I get this polynomial. When I simplify those, I end up with 30 plus 25. And then when I add 30 plus 25, I get my final answer of 55. So another method to combine functions is called a composition. So this is a new method. Given f of x and g of x, the composite function looks like this, f open circle g of x. And that's defined as f of g of x, meaning you are plugging in g of x into the function f of x. So let's look at a few examples of that. It is very important that you pay attention to the order. F of g of x looks like this. It's f of g of x. So I take my function f and I'm plugging in g of x. G of x is x minus 2. So this is telling me to take the function f of x and plug in x minus 2 everywhere I see an x. So f of x is here. It's x to the third plus 1. So instead of x, I plug in x minus 2 cubed plus 1. Well, x minus 2 cubed means x minus 2 times x minus 2 times x minus 2, and then plus 1. So I would multiply 2 of those together and get x squared minus 4x plus 4. Then I would multiply x minus 2 again. When you do that, you get x cubed minus 6x squared plus 12x minus 8. And we still have to add 1. So your final answer, when you combine all your terms, is x cubed minus 6x squared plus 12x minus 7. So now let's look at g of f of x. So this time it's the opposite. We're taking f of x and plugging it into g. So that's g of f of x. So I'm taking my f of x and plugging it into g. So f of x is x cubed plus 1. So that's what I'm plugging into the g. So since g is x minus 2, now I have x cubed plus 1 minus 2. X cubed plus 1 minus 2. And then I just combine like terms, and my final answer is x cubed minus 1. Two more examples. So now I'm doing h of g of x. So that means I'm taking the function h and plugging in g of x. G of x is x minus 2, so I'm plugging in x minus 2 into the function h. So everywhere I see an x, I plug in x minus 2. So that gives me 3 times x minus 2 plus 5. Simplifying that, I get 3x minus 6 plus 5. And when I combine all my like terms and solve it, my final answer is 3x minus 1. For number 4, we're going the opposite direction. We're doing g of h of x. So that means I'm going to take h of x and plug it into g. So that means g of 3x plus 5, because that's what h of x is. So since g is x minus 2, I plug in 3x plus 5 for x. I get 3x plus 5 minus 2. When I combine my like terms, my final answer is 3x plus 3. The final type of problem you might see is finding the numerical value. So given the same functions as the problems before, we're now going to find the value. So now f of g of 3 can be written like this. So what I'm going to do, whenever it's a numerical value, you kind of always work from the inside out. So I'm going to plug the number 3 into my inner function, g, simplify that down to a numerical value. Then I'm going to take that value and plug it into f, and then simplify my answer to get my final value. So when I plug in 3 into g, g is x minus 2, so I get 3 minus 2. 3 minus 2 is 1. So now I'm going to take the number 1 and plug that into f of x. When I plug in 1 into f of x, I have 1 cubed plus 1. 1 cubed is 1, plus 1 gives you an answer of 2. For number 2, I'm doing g of h of negative 6. That can be rewritten like this, g of h of negative 6. So I'm going to start by plugging negative 6 into the function h. So this is the function h with negative 6 plugged in. 3 times negative 6 is negative 18, plus 5 is negative 13. So now I'm going to plug negative 13 into the function g. So that's negative 13 minus 2. So negative 13 minus 2 gives you the value negative 15. Number 3 is h of g of negative 1. So that can be written like this, h of g of negative 1. So the way you start is plug in negative 1 into function g. So when I do that, I get negative 1 minus 2. Simplify that, and I get negative 3. So now I'm going to plug in negative 3 into the function h. So 3 times negative 3 plus 5. Well, 3 times negative 3 is negative 9, plus 5 gives you an answer of negative 4. My final problem, h of f of 2, means this, h of f of 2. So I'm going to plug in 2 into my function f, which looks like this, 2 cubed plus 1. When I simplify that, I get the number 9. So now I'm going to plug in 9 into the function h. So 3 times 9 plus 5. 3 times 9 is 27, plus 5 gives you your final answer of 32. Be sure to try these problems and try your Delta Math problems. If you have trouble, make sure you join me at office hours or during our instructional block. Thank you.